Question number 73. A delectable problem where we have conservation of energy not taking place because of friction, but we're going to still employ our understanding of what happens with energy. So we start with elastic potential energy, and I know that because I see a compressed spring here. From reading this problem, I know up the incline there will be work of friction, and then in the end I have my gravitational potential energy, because if I say that this is my zero level, then it acquires a 2-meter height plus kinetic final, exits or gets off this incline with some sort of V final, which for projectile motion will be our V initial, and then we will deal with projectile motion after that. So let's figure out at least with what velocity it goes up the incline. So I'm going to say my kx squared over 2 plus mu mg cos of 45. Displacement will be 2 divided by sine of 45, and that is because this is 2 and that's the hypotenuse. And then I noticed that cosine 45 and sine 45 is one and the same. So this is cosine of 180 because force of friction is down the incline, and that will be equal to mgh, which is 2 meters, plus mv final squared over 2. We are after v final, so I'm going to multiply everything by 2 first, and then so I will have kx squared minus 2mg, since I'm multiplying by 2 anyway, and that will give me 2 mu plus h equals mv final squared, from where v final is going to be a root of kx squared minus 2mg, 2 mu plus h over mass. Let's plug in the numbers. I got 8.09. Think about what's happening. So we found this to be 8.09 meters per second at 45 degrees. I know that at half time Vy is going to become 0. So if I take my 809 root of 2, which is sine of 45, because that will be my V initial y is going to be 809 sine of 45, which is root of 2 over 2. And then if I divide that by g, which is 9.8, and if I double that, that will give me the total time in the air. So ultimately I have 809 roots of 2 over 9.8 would be time in the air. And then if I am looking for the distance, because they are ultimately asking us to find this d right here, again it's going to be 809 root of 2 over 2 times 809 root of 2 over 9.8, which was time, right? So let me consolidate that. This, and this cancel. So I have 809 squared over 9.8 gets me 6.67 meters. That's the distance. It's a beautiful problem.